Hello everyone. So this is the fourth video of the AI engineering course. In the last session, we covered what are AI agents, how LLM orchestration is different from being an AI agent. We decided that we will be covering and building two agents, one very basic in which we will just talk about how the tools are called, and then we will also build an intermediate level of agent and we will discover how it is different from the basic agent and we will create and develop it also. As the session was getting very much bigger, so we decided to stop where we were able to cover till the basic agent and its coding portion. In this session, we will continue our journey and we will talk about our intermediate level of agent, how it is different from the basic agent and do its coding. So let's start. So yeah, intermediate level agent which we are trying to build here, the problem statement is we have to build an agent that delivers puzzles one at a time. So if you remember from our last session, we in the basic we build an agent that understands the user intent and decide which puzzle to retrieve from the file. So if you have not seen the video, I will highly recommend to see that video because you will be able to understand the context very easily. So here the user will say, right, give me a math puzzle. So our agent is able to decide, like the user is asking about this category math and is able to suggest the right tool, which is a function that can be invoked in order to fulfill the user objective. In this session, we will extend it further. We will build an AI agent that delivers puzzles one at a time. It remembers which puzzles that have been used. So we will be using state tracking. It keeps running until all the puzzles are exhausted. So we will be using the agent loop and send the tool results back to LLM for multi-turn decision making. So there are various things which are new here. We'll be introducing agent loop, which make the program more agentic. Right? So if you will see here the level of agency slide, which we have covered in the previous session, the basic agent was 2 star because it was just able to determine the function execution. This agent, the intermediate level agent, we extend it further, and as we are introducing the agent loop, so it is becoming the 3 star because agent will continue to run until the user objectives are met, and it controls the iteration and continuation. So just quickly, like how our basic program is different from the intermediate level program, there is a single call in the basic agent, and there are multiple calls. There is no state tracking. Here we are tracking what puzzles have been used, so that is giving the response based on the puzzles that are left. The tools, we have used one tool here. Here we are using two tools. Basically, they are functions, get available function and get puzzle. There is a one shot response. It is multiple turns in an intermediate agent, multiple turns with history. There is some sort of decision making there also. User decides, but user decides the category, right? But LLM is able to understand the intent. Here, agent decides which puzzles to be given to the user. It forgets immediately, it remembers across the turn. So memory, some kind of memory management is also there. Interaction is once an exit, it is interactive until the quit. This is the way how our program is becoming more agentic in nature. That's why it is an intermediate level program. So yeah, let's start doing our coding. So this is the basic agent. If you recall, we have developed in the previous session. So let's create another file. We will call it intermediate agent.py. So whatever packages that are needed to make it work, we already installed in the last session. So there is nothing new here. We'll just use our import statement. So these are our import statement. We just need .env and light LLM packages. Nothing much, nothing fancy about it. We are loading the environment variables. Before starting further, just two things to note. Whatever coding which we are doing it here, all these programs will be available on my GitHub repo. I will give the link in the description. Now, before going further, let's quickly see the flow, which will help you to understand what we are going to do. So user will be asking, give me a puzzle, and our agent loop will start. There will be first LLM call. It will invoke the get available tool, which is a function, add the detail about this tool and the result in the messages. This result will be passed to the LLM. Then there is another second LLM call because in the second LLM call needs to find whether they are available puzzles or not. So if they are available puzzle, it will get one of the available puzzles, maybe one, maybe two, maybe three, anyone. Because in our text file, if you see, there are three puzzles. So whichever one is available, it will help to get that. Now let's go to our program and basically start the next part. So we know like the function has to read from the file. So this is the file path. Then there's an important part. We will be using the state tracking. So let's discover it at the on the very top. So this is a set which we are using it to find out which puzzles have been used, which puzzles we have already given to the user out of three. There could be 10, there could be 20. In our case, we have just three puzzles. So it is keeping track it here, which puzzles have been used. Basic agent, if you see, after this, we have defined the categories here. We are not using the category. It's just making it little simple in nature. We are just using the number 1, 2, 3. But if you see here, like we have defined the method. So similarly here, we will define our two methods. So the first method is the get available. Now it is a new method. We will explain it. So this is our first method, which is get available puzzle method. So let's go it line by line. So we are opening the file here, which is present on the path which we have decided above. And then these statements we already covered in the last session. We are splitting it by this particular pattern. This pattern, and the result is stored in this data structure puzzles. And then we are removing the white spaces here. So the next part is we have to find out like which puzzles are not used so that we can return to our program that these are the available puzzles. So what we are doing it here for whatever puzzles we are getting after splitting, we are we're matching the text based on this particular pattern in that puzzle. So if you will see here, we are matching this. If whatever is the match puzzle name, first name which we have found here. So this is the first puzzle name which we have found based on the pattern. And then if this puzzle is not there in the used puzzles, we are splitting the puzzle based on the new line correct. We are basically splitting it here. So we are getting this content. Add this line in the available array. So it will store it puzzle to this line and this line in the available array. Once this for loop is executed, we are using the if statement to find if there is nothing in the available, then just return that no puzzles are available. But if something is present, we are then joining the content. So what it is doing basically, if you will see here, I have mentioned it somewhere. Yeah, in the available list, this will be the first line, like something like this. In this line, basically, for every puzzle in the available, we are adding this dash before the puzzle. So it is doing like this one. If you see here, we are adding it here. And then when all are done, we are joining them with the new line that the final output looks like this. Available puzzles are this one. And then we have the some exceptional scenarios we have handled. So next method, because we're working with two tools. So the next tool is our get puzzles, just quite similar like what we have done in the basic agent. Here just we work with the number instead of category. So again, we open the file. We are again splitting. Then we are basically finding the note that, right? So this our method, it is having one particular parameter, which is the number. It can be any number, 1, 2, 3. So it can be number 1, it can be number 2, it can be number 3, based on the puzzles which we have in our list. So LLM is deciding, right? LLM will pass this number. Based on this number, so say the number 1 we have got it here. Puzzle 1 it is there. So then for every puzzle which is there in this file, we will just return its content here. We're returning the content and we are adding the same in the use puzzle also, so that the next time the same puzzles should not be given by the LLM. And then as we have done previously, we are registering this both of this function as a tool. LLM will be returning us the string and we have to invoke this method. So for that purpose we are using this registry. Now the next part is we have to define the schema of all these functions. We are not sending these tool definitions to the LLM, we are sending the tool schema. So this is the tool schema. It defines what each function does. So what this function knows what each of this tool actually perform. So the first function we know it is getting the one of the available puzzles, and there is no parameter we are passing. And the second function is our get puzzle. If you see here, this is a standard format, and anytime you have to define the function, you have to use the similar format. So the parameter wise, we have mentioned like it will require a number which is integer. For example, the number is 1, 2, 3, and it is a required parameter. So if LLM decide that it has to invoke this function, it knows that a parameter needs to be passed, and that is the number, and it is required. So it also has to suggest the parameter also. Now the next question is we have to define the system prompt, right? So this is our system prompt. It's very important, but here our system prompt is not just telling the operation boundary, it is also telling how the LLM should how LLM should check on what basis it has to invoke the tool. So its workflow is basically first it check what puzzles are available using the get available puzzle function. If the puzzles are available, pick one and retrieve it using the get puzzle. So essentially this is a multi-step process. This is why this is there is an agent loop. So in the first step of the loop, it will first check which puzzles are available. In the next step, once it knows the result from the first LLM call, the second LLM call will basically retrieve the result using the get puzzle. So suppose a puzzle 2 and 3 are available, the LLM is free to randomly choose either two or second or third puzzle, and then it present the puzzle to the user. If the user asks for the another puzzle, repeat the process. If no puzzles are left, then inform the user all puzzles have been used. And there are some further rules. Always check available puzzle before retrieving. And the important criteria, please always note down. always mention the not criteria also, the opposite. So what it intends to do and what it should not do. Now next thing is the agent loop. This is the most important bit which we are covering today. Now this is the agent loop function. So before going to the agent loop function, which will be called in the loop, let's define the main function, and I will cover both of them, don't worry. So main is called it's by itself. So let's start with the main, right? So when this program will be run, now this is our main function which will be invoked. Some print statements, proper structure at the top. Now, when our main program is run, so if you remember from our previous session, once we define our tool definition and tool schema, then we start defining our message, right? It's exactly the same here we are doing. I did the system prompt and then we have started defining the message. Let me show you that what I meant here. So this is the last to last program which we have done. So if you will see here, we we are basically defining the message, making a call to the LLM and handling the response. And here also we are defining the message. All the other formalities are done, but here the change here is before calling the LLM, we are using the agent. We are using the loop. So this is not the agent loop. User can ask multiple puzzles. So this is loop is controlling that. So we are getting the user input like give me a puzzle. If the user types something like quit exit, then we break. But if it is user is not asking, we will continue. And then see our we will call our agent loop function. Whatever user has asked, we are passing it here, and we are passing the messages. So we the system prompt which we have wrote above, and then let's now go to our agent loop function. It get the user input, it gets the message, and then what it is doing basically, it is adding the whatever the user input with the role as a user. We covered all these things in detail in earlier sessions. And now this is the most important bit, which is our agent loop. So the first call is made to the LLM. We pass the model, right? This is the something which we have done many times. We are passing our tools and then we are getting the response back. User can get message.content or message.tool underscore call. We get the response from the LLM, and basically because in this case, we are not interested in getting any response from the LLM. We are just interested that it will invoke the tools, right, to get the response. It should not apply its own brain. It should rely on our tool. That is what is making this program more agentic. So this is the exit criteria. If there is no tool calls, LLM decided I cannot invoke any tools. So then it means time to exit. If we will go here, the visual loop which we have covered. So you will see the first time agent has to invoke get available. Once suppose say some puzzles are available, it will invoke the get puzzle method. And once it is done, the user objective is met. Then it will come out of the agent loop. Then no, there is no tool call, and that's how the it will exit. So there is something agency here which is involved. LLM is making what it has to do. We are not asking it that you have to invoke this tool. LLM is deciding on its own, and then it is making the decision to exit also. It's the same thing here. If there is no tool call left, come out and give us the response. So here we're getting the message or content. But if there is a tool call, so suppose the agent decided that I should be, invoking this method, which should be the, natural flow, that I should be invoking the get available puzzles method. So this is the first step to meet the user objective. So we will get the tool name, we will get the arguments, and then we are calling it, right? So we are calling here the function get available. We are just printing some of the result, a portion of the result. Then this is the very important bit. Whatever is the result, so we are passing that back to LLM so that in the second call, it understand what was executed in the first call. So what we are passing? So we are passing role as an assistant and content as a none, and as a in the tool calls, whatever the tool call that was recommended by this LLM call, which is get available puzzle here. So try to understand it. Get available puzzle. Till now, we have only done the get available puzzle. So this is one. So in the next call, so we are in this call we are letting it know the LLM that this call was made, and we are adding another message where role is equal to tool. Now this is important. This is no role, new role which we have not talked about earlier. But if we have to pass the content of the result of the tool calling to the LLM, then we will use the role as a tool. Here we are just saying like this tool call was made. We are not giving it back the result. But here when role is equal to tool, we are telling this particular call was made and for this particular ID. So this is the ID of this tool call. This tool call ID something LLM generates at the backend. So if you have not seen it in the previous session, we talked about it. So this is the idea of every tool call which is generated. So we are passing so that LLM know, right? This result belongs to which particular tool calling. So not only we are passing which tool call was made, we are passing the content, the result of that tool call back to the LLM. So this is the first time this will be done. Actually, this is the while loop which is running, right? So then again we are making the call back to the LLM, and LLM has the result of this particular the tool call which was done previously. This time LLM know, like the get available puzzle was run previously, and this time it will ask to invoke this function, the get puzzle, because it knows like which puzzles are available. For example, now active state puzzle 1, 2, 3 all are available. So it may try to invoke either one of them. So it will ask like, okay, invoke the puzzle 1. It will give that result, invoke the get available puzzle with the right parameter, right? So we will get it here. So here in this case, we will get the parameter as a get puzzle, and the parameter might be 1. In this way, the tool call will be made. The second tool call will be made. We will run it here, run it, making sense like, we will get the puzzle back. So here we are getting the puzzle back, and then we are again adding the details to the messages. We have made the call, right, to the LLM, and then the next time when it will run this while loop run, this agent loop run, it will determine, okay, to make the user objective is met, it has asked for the puzzle. We find like which puzzles are available, and we have given him, the user, the right puzzle. So the job is done. So the third time it will return message tool calls as a none, and we will return the message content like yes, no further tool call is required. So guys, in this way this program is structured. I hope you understand some of the key aspects about this program. Now, before going through some of the key or some of the important bits again, let's try to run this program to see how it works. Yeah, so see, it is asking me like, it is going to the main method, and it is asking me, right, for the user input from here. It is asking for the user input. Let's give the input, give me a puzzle. So you see here, like, it is saying like, the tool called get available puzzle, the result available puzzle, right? So it is showing me like these three puzzles are available, and it got me the puzzle number 1. Now let me ask once more. Give me next puzzle, please. Now puzzle 2 and 3 are available. It is giving me the puzzle number 2. If you see here, this is the puzzle number 2. How many puzzles are available? Let me ask this question now. So see, it is as per because of the our boundaries which are set in the system prompt. If user is asking like anything like puzzle content, anything except the puzzle content like count, hint, etc., respond with I can only provide puzzles that two one at a time. That two one at a time. So it is providing the same. So yes, so in this way, I think our program is working fine. So I hope like you're able to get the gist, you're able to get the key ideas behind this program. Let's revisit like you have seen the agent loop, how it works. You're able to see how we are passing the result of tool call back to the LLM with the help of messages. You have seen how we have managed the state with the help of state tracking, with the help of this set method, which is our use puzzle. When the puzzle is given to the users, we are adding in the use puzzle. We are checking whether the puzzle is available or not. So yeah, in this way, this program is structured. Quickly, some of the things which we have covered. So we have seen that in this program there are multiple LLM calls. We have used state to manage the track the puzzles, and here it will seems like it's one of the standard things to do in any program, right, in such kind of program. But this is just to give you idea, like when we will cover advanced topics, as we have mentioned lang graph, you will see how the state management becomes so much important. We have covered multiple tools, and the conversation is multi-turn with the history, and the agent decide which puzzles to invoke. There is some sort of memory management. It remembers across turns because of the state management, which puzzles have been invoked and which are not. And the interaction is interactive. So interactive loop is there until the user asks for the quit or the puzzles have been consumed. So yeah, I hope like you're able to understand now how to build the agentic programs. At least some of the bits we will now build on the basis of this knowledge. We will cover other advanced agentic programs. In the next session, we will be making our program more reliable and production grade by introducing concepts like max iteration guard, token cost tracking, input validation, retry with exponential backoff, and wall clock timeout. So guys, that's it for this video. I hope you like it. I will wait for your comments and questions. Thanks for joining today's session. Thanks again.